In this video, we're going to look at how we can identify the domain of a radical function. So we'll start with defining a radical function and looking at what this looks like in general. So we have it written down right here. This looks a little messy because it is in standard form. So if we're going to look at it kind of like a quadratic, it looks more like this. So we have this a value, which just like in the quadratics, this is going to determine how wide it's going to go, the same way as if we have the difference between these two kinds of quadratics. And we'll look at exactly what that looks like in the next video. And then where this h and k is going to be a vertex. And again, we're going to look at exactly how this works in the next video. But we can talk about some of these things here. hk, and if we're comparing this equation and this equation, we see it's very similar to when we were factoring before. If I have bx minus c, I'm trying to figure out where that's 0. So really that's telling me this h is this c over b. So this is only going to come into play when we have some decimals. And again, I really don't want to get into it in this video. But suffice to say, we have a vertex at hk. The a is going to determine how wide this is. So if it was a square root, the difference between it going very high very quickly or very low. And then n is going to determine what kind of root it is. So square root, cube root, fourth root, fifth root, etc. So if we're trying to focus on the domain in this video, we want to think about the values of x we are allowed to plug in. So we have a couple questions to ask ourselves. Can we take the square root of a negative number if this n was 2? So no. That tells us that our domain is going to be restricted. And if we think about that, what that tells us is this bx minus c can't be negative. And how we write that is that it's greater than or equal to 0. So if we want to find the domain of a square root function, all we would do is take what's underneath the radical and set it greater than or equal to 0 and solve. Now, can we take the cube root of a negative number? We actually can. And so if we think of cube root as being something like us being able to write it as, say, 2 times 2 times 2. Right? If we think of cube root as taking 3 of a kind out, if this was a negative 8, well, I can think of this as 3 copies of negative 2. So we actually don't have any issues with cube root. So for cube roots, the domain would be negative infinity to infinity. Now, I didn't write out what the domain would be in this one because it could look one of 2 ways. It could be from negative infinity to solving that out, or it could start from c over b and go to infinity. And how we'd figure that out is just figuring out what this looks like. Right? So if we had, say, the function square root of negative 2x plus 5, we set that negative 2x plus 5 greater than or equal to 0. And we have this important thing when we divide by a negative, we flip the sign. So we can see here in this case, our domain is everything less than or equal to 5/2. And you can see how that looks like this domain in this case. Then on the other hand, if it was something like square root of 2x plus 5, when we sit and solve the denominator greater than or equal to 0, since we weren't dividing by a negative, it doesn't flip, and so we can see our values are greater than this point. So we can see those are the two different things that we could end up having. And then just as a quick side note, if I had something here, or if I had something here, these values aren't going to change what I'm allowed to plug in for x, because they're not changing what's under the radical. So it actually doesn't even matter, and they could be anything. It would still be the same domain here. Okay, so we know what's happening with square roots. We're going to set what's under the radical greater than or equal to 0, and that'll give us the domain. For cube roots, everything is in the domain. We don't have any issues. So can we take that and say, well, for every even root, we'll do the same thing as square root? And we can. We can't take the square root. We can't take the 4th root, 6th root, 8th root. These are all going to give us imaginary numbers. And in the reals, we can't take an even root of a negative number. So we'll do the exact same thing. Take what's underneath the radical, set it greater than or equal to 0. And then for odd roots, it doesn't matter whether we have 3 or 5 or 7. We can always take the odd root of a negative number and it'll still be real. So our domain is, again, everything. So just summing that up, written, to find the domain of an even radical, we set what's underneath the root greater than or equal to 0 and solve. Keeping in mind that if we divide by a negative, we need to flip that inequality. And since we can take the odd root of a negative number, our domain is everything.